Okay, in this part of our lesson about inverse functions, we're going to look at the conditions because not every function has an inverse. And if you kind of go a step before that, if you remember, we say not every equation or relation actually is a function, right? There's a test called the vertical line test to determine if a relationship or a graph is actually a function. Well, this is getting into more detail about the behavior of a function. So one of the conditions for a function to have an inverse is for it to be one-to-one. So up here in the upper right, I tell you what one-to-one is. What happens is with that function, every x maps to exactly one unique y and vice versa. So, we look at this set of points here, and this set of points, if we'd say, is it one-to-one? Well, it's not even a function because it's got x equals 1 here and x equals 1 here. So there's repeating x values. That would fail the vertical line test. Now if we change that and we say we make this a 2, well now it's a function and it's also what we say one-to-one. Each x goes to one unique y. There's no repeating x values or repeating y values. What if we change that to a 2? Well, now we have a problem. If we have repeating y values, what we're saying is two different x's yield the same y value. So now this would be a big no for being one-to-one. Second one, f of x equals x squared. So this is also not one-to-one. It's a very classic not one-to-one function. Reason being, if I take 5 and I plug 5 in, well 5 squared is equal to 25. If I plug negative 5 in to that function, well negative 5 squared is also 25. So here we have two different x's giving us the same y value. Okay? This is now not one-to-one. Inverse functions are the hallmark, or they're really the baseline of what's known as cryptography. Cryptography is code making, code breaking. I took a course on cryptography and read a pretty cool book just for fun about it. And the idea with cryptography is we use numbers to code things. Your credit card number, we code words that way. And if we're going to be able to decode them, we want our coding, our method to code, to be invertible, like able to find an inverse. So for example, if we say, well, the result's 25, and we need to work backwards and figure out what it is, if we use x squared, there's a problem. Because the question becomes, did that 25 start with 5? Or did that 25 start with negative 5? So we have two different x's giving the same y value. So this one, not one-to-one. Now, with functions, I said to determine if it's a function, we have this test called the vertical line test. What's great, all we do is turn that sideways, and if we want to see if a function has an inverse, we use what's called the horizontal line test, because that'll test to see if there's two different x values giving the same y value. So we're going to head over to Desmos.com, and I've got up here first, I've got graphed y equals 2x plus 5. We looked at that in the last video. And it passes the horizontal line test, because if I run a horizontal line down through that graph, it only hits it one time. So 2x plus 5, it's a function and it has an inverse, and we found the inverse in the last video. Let's turn that off, turn on y equals absolute value x. So it's a function, it passes the vertical line test, but it fails the horizontal line test. So horizontal line's hitting it here and here, therefore it is not one-to-one, not invertible. What about x cubed? What do you think there? Do you know x cubed? Now, there are a lot of variations. Most variations of x cubed, they'll go up, back down, back up, and they'll fail the horizontal line test. But just in x cubed, it passes. Okay, it gets horizontal for a moment, but only one moment, so the horizontal line test works with this one. In the last video, we looked at y equals x squared a little bit. This one fails the horizontal line test, and so it's not invertible. It doesn't have an inverse. But if you remember, I mentioned a catch, and that catch is if we want to use a piece of a function to make an inverse, we can do that. So for example, with a parabola y equals x squared, what happens, this is a pretty clean or obvious one, squaring negative numbers gives you the same result as squaring positive numbers. So if we just kind of put a condition on it, and it's a little different on paper, we might put a comma and say x is greater than 0. In Desmos, I bracket it, I put the condition in, and then close that. And now what I've done is I've chopped off the left half of the parabola. Well, now it passes the horizontal line test, and its inverse, if you remember from before, is of course the square root of x. We'll look at one unusual one. We've got this from here, y equals 2x plus 5 over x minus 1. What do you think about that one? Here's the graph, and while it's kind of off in the corner there, it does indeed pass. So down here, only 1 point. There's a vertical asymptote at x equals 1, and there's a horizontal asymptote at y equals 2, but a horizontal line never crosses through this graph more than one time. So it's invertible. That means we can find an inverse for 2x plus 5 over x minus 1, and we're going to do that in the next part of the lesson.